Welcome to Selection Sathi. Today we cover C++ advanced features, move semantics, lambda expressions, exception handling, and the rule of 5. These modern C++ features are what separate beginner from advanced C++ programmers. Let's dive in. First concept, move semantics. In C++, copying a large object like a vector of 1,000,000 elements is expensive. O of n. Move semantics solve this by transferring resources instead of copying them. A move constructor takes an value reference, denoted by $ampersand. It steals the internal data pointer from the source and sets the source to null. This is O of 1, just swapping pointers instead of copying data. Std move is a cast that converts an value to an value reference. It doesn't actually move anything, it just tells the compiler, this object is ready to be moved from. Second concept, lambda expressions. A lambda creates an anonymous function in line. The syntax is square brackets for capture, parentheses for parameters, arrow for return type, and braces for the body. The capture clause controls what variables from the surrounding scope the lambda can access. Square bracket equals captures everything by value. Square bracket ampersand captures everything by reference. You can be selective. Bracket x captures x by value, bracket ampersand x captures x by reference. The return type is usually deduced automatically. Lambdas are heavily used with STL algorithms like sort, for each, and remove if. Third concept, exception handling. The try block contains code that might throw an exception. Throw creates an exception object and immediately unwinds the stack, calling destructors along the way until it finds a matching catch block. The catch block handles the exception by type. Always catch by const reference, catch of const exception ampersand e to avoid slicing derived exception types and unnecessary copies. Catch with ... catches any exception type, use it as a last resort fallback, but prefer catching specific types. Fourth concept, the rule of 5. If your class manages a resource like dynamic memory, you need to define 5 special member functions. The destructor to release the resource. The copy constructor to deep copy the resource. The copy assignment operator to clean up the old resource and deep copy the new one handle self-assignment. The move constructor to steal the resource from a temporary. The move assignment operator to clean up, steal, and nullify the source. If you define any one of these, you should define all 5. Alternatively, use equals default or equals delete for ones you don't need. First example, move constructor. Class buffer has an int pointer data and an int size. The move constructor takes a buffer value reference. It steals the data pointer and size from the source, data equals other.data, size equals other.size. Then it nullifies the source, other.data equals null pointer, other.size equals 0. Usage, buffer b2 equals move of b1. This is O of 1, no data is copied, just two pointer assignments. After the move, b1 is empty and b2 has all the data. Second example, lambda with capture for filtering. We have a vector 1, 2, 3, 4, 5, 6, 7, 8. We define a lambda is even that takes an int and returns true if it's divisible by 2. We use remove if with a lambda that checks if a number is odd. Remove if moves all matching elements to the end and returns an iterator to the new logical end. Then v.erase removes those elements permanently. Result: the vector contains only 2, 4, 6, 8. Third example, custom exception. We define class div by 0 that inherits from std exception. We override the what method to return the message division by 0. In our divide function, if b equals 0, we throw div by 0. The calling code wraps the call in a try block. The catch block catches const div by 0 reference and prints e.what. Output division by 0. Custom exceptions make error handling clean and specific. Fourth example, copy versus move performance. We have a vector with 1 million integers. Copying it, autocopy equals big. This allocates a new array and copies all 1 million elements. O of n, moving it, auto-moved equals move of big. This just swaps the internal pointer. O of 1. After the move, big is empty with size 0, and moved has all 1 million elements. For 1 million integers, copy takes about 4 milliseconds. Move takes about 1 microsecond. That's 4,000 times faster. Quick tips. Tip 1. std move doesn't move, it just casts to rvalue reference. The actual move happens in the move constructor. Tip 2. Capture by reference in lambdas when the lambda doesn't outlive the captured variables. Tip 3. Catch exceptions by const reference to avoid slicing and copies. Tip 4. If you define any of the 5 special functions, define all 5 or use equals default and equals delete explicitly. For more concept videos like this, download the Selection Sathi app. Like and subscribe. Thank you.